Welcome to the walkthrough of the frequently made mistakes for assignment 1B. First and foremost, make sure your code compiles and passes all of the JUnit tests and instrumentation tests before you push it to your GitLab repository. Too many people had compile errors and/or problems with their code that would have been picked up by running these tests, so make sure you do that before you put your code in the repository for me to review. Secondly, under no circumstances should you be removing the to-do comments. Doing that makes the code much more difficult to review, so I won't review it if you don't fail to follow this advice in the future. Let's take a look at some of the common problems with the Spinlock Hashmap manager. First, please don't initialize any of the fields in the field declaration section inside the class. These fields should be initialized inside the build model method. In particular, don't initialize the semaphore because you don't know what the count is at this point. And moreover, make sure that you create your semaphore to be a so-called fair semaphore. Remember that by default, if you use the constructor for the semaphore that has only a single parameter, it won't actually be fair. It will be not fair or unfair, which is not the semantics you want. Let's take a look at some of the problems with the build model. This is a weird one. The person was attempting to initialize the Palantiri map by iterating through the uninitialized Palantiri map. So of course, that's not going to make any sense whatsoever. You need to initialize the Palantiri map by iterating through the list of Palantiri. Another problem we have here, this isn't so much a problem, or is just something to do a better job of. Please take a shot at using the Java 8 for each method rather than using a for each loop. And something else that is a problem that you shouldn't be doing, you don't need to make a new Boolean object. You can simply give true here, which is pretty straightforward. It was entirely unclear what the code here was trying to do. I'm not even sure how this compiled. So this goes back to making sure that you're compiling your code before you submit it. So this code made no sense to me whatsoever. And moreover, you should make sure that you're giving the appropriate initial count for the semaphore. It should not be the value 1, that's for sure. You want to have it be the number of available Palantiri, or number of total Palantiri that you can have, which is described in the comments. Let's take a look at the acquire method. People did acquire in lots of interesting and in some cases strange ways. So first and foremost, don't create a new Palantir. That makes no sense. You should use the Palantir that are already available in the Palantiri map. Secondly, don't be calling available permits on semaphore in this context, and also don't be calling acquire uninterruptibly. If you read the specification, it says clearly that you're to acquire the semaphore in an interruptible manner. And the reason doing that, of course, is to make sure that if you interrupt the code, which we'll cover in later versions of the assignment, that you don't end up blocking for too long. Don't throw an exception if there's no semaphore available. The whole point of this is to block until a semaphore is available. So throwing an exception is just causing trouble. And it's the wrong semantics. Here's another thing. Take a look at the isCanceled method reference, which is inherited from the Palantiri manager class. That's what you should be passing as a method reference to the lock method, so you can have that method be canceled properly. Don't be defining your own, in this case, anonymous inner class. That makes no sense. You should be using the method reference that I just described instead. A lot of people made the following mistake. They were using calls to get and replace as they looped through the key set in the map. That is very inefficient because getting and replacing have to go and search through the map starting at the beginning each time, which is inefficient. A much better way to do this is to use a for each loop that will iterate through the entry set for the map and then use the various methods defined on a map entry, such as get key and get value and set value and so on. So that's a lot more efficient and a lot cleaner. Also, make sure you don't unlock the Spinlock inside of the loop as they're doing here. Instead, this should be pulled out and unlocked as part of the finally block in a try finally catch clause or try finally exception handling clause that surrounds the for loop. You don't want to be doing the unlock only here, because if for some reason you can't find something in the map, which would be bizarre, you don't want to fail to unlock the lock. Here's another odd implementation of acquire. It's doing a try lock and get available Palantiri and spinning, and it just makes no sense. All you need to do is simply lock the Spinlock. In this case, it was a reentrant Spinlock, but in general, it's whatever Spinlock your program is initialized with, depending if you're doing the grad version or the undergrad version. Here is yet another incorrect implementation of acquire. As you can see here, this person is trying to spin on the semaphore, calling try acquire in a non-blocking mode, which makes no sense. You should be using the blocking call to acquire. That's the whole point of this. This person is writing out a lambda expression, which is really not the right thing to do. You want to use the is canceled method that's defined in the Palantiri Manager class and use it as a method reference. I don't think that this code works correctly. This person's trying to iterate through the map using for each on the map and trying to set one of the values that's iterating over this to false. That doesn't actually work properly, I don't believe. That doesn't actually update the value in the map. It just updates the value of the variable j, which is part of the lambda expression. So that's also incorrect. For some reason, this person also wanted to call release here. I had no idea what the reason was for that. That's not correct. And also, and I'll cover this in a couple other places too, always get in the habit of releasing a lock in the finally block of a try finally clause. So don't just call unlock, because if an exception is thrown, the lock won't be released. Whereas if you do it in a try finally block, then it will be released. Speaking of releasing, let's take a look at some of the common problems in the release method. And here, the first thing you always need to make sure to do is check whether the Palantir is null or not null, depending on how you write your code, before you do anything else. If someone passes a null Palantir, then you just want to return without doing anything. Otherwise, you will probably get a null pointer exception somewhere or corrupt the state of the map. Another thing to note here is that this particular implementation, as you can see, is incredibly sparse, and it's not locking anything. It's not acquiring the spin lock. It's not releasing the spin lock. Using that version of replace is overkill. I recommend you use put instead. And the semaphore is also not being released correctly here either. So lots and lots of problems in that code. A lot of people actually have this particular problem. Here's yet another version of release that has some problems. You don't need to be using get to check if the Palantir is in there. Just need to check the return value from put. That'll tell you whether it was there or not. Likewise, you don't need to check contains. You should also just call put, which will do the right thing. And make sure that you only call release if the call to put succeeds. So if put gives you back an unexpected value, then you do not want to call release. So take a look at the return values of put on a hash map and kind of reason about what you expect the behavior to be here. Let's take a look at Spinlock. You can see that Spinlock has to be implemented in a certain way. Whatever you do, don't write code like this, which shouldn't even be compiling because there's no type after public and before mowner. So this looks like code that didn't even compile. So that's a bad thing. I was tempted not to review this code at all, but this is an easy error. The compiler should have caught that for you. Here's the try lock method. This particular method, I don't even know what's going on here. There should be one line of code here, and this is not that one line of code. It's way too complicated, so there should just be one line here. This code is a little better, but unfortunately, it's not atomic because we're doing a compare and set followed by a get, and those are two operations, and the whole point of doing atomic operations is to do one operation. So you need to rearrange this code so it just does one thing and returns the result from that one thing. Here's yet another problem with another implementation of trylock. First, don't confuse the heck out of people by naming your local variables with an M prefix. The M prefix is intended only for fields in classes. So that if you're going to do something like this, which you could do or not, just call it owner, not mowner. Also, don't put the logic to check for a recursive call in try-lock. That's not where it belongs. It belongs in lock. And this particular code doesn't make any sense because it's not actually doing anything correct at all. I don't even know how this code could compile because it's supposed to be mowner is supposed to be an atomic Boolean, not something that has strings associated with it. So this is just nonsensical code. I also don't see how that code would compile. Let's take a look at some problems with lock. A lot of people forgot to use try-lock. You should be using try-lock in the context of lock. That's why it's there. It's a helper method. It's abstracting away the details of doing this check. This particular code is also buggy for other reasons. It's not atomic because there's two operations, and therefore it's not properly thread safe. For things to be atomic, they only can do one thing, and they have to encapsulate the behavior atomically in that one thing that you do. Here's another problem. Don't be calling mowner.get. That's not the way it works. That's not atomic. And for some reason, there's just a random call to try-lock with nothing else around it. That makes absolutely no sense. You're going to have to call try-lock in a loop, and you're going to have to check to see what the right return value is from try-lock in order to handle the code properly, the logic properly. Here's some more problems. Again, use try-lock. Use the try-lock helper method. Don't just make the call to compare and set directly. If you're going to throw an exception, explain what went wrong. Add a string here. Don't be setting the value to true. That, again, is unnecessary due to the semantics of try-lock. And it's also not thread safe because now you're doing something else that doesn't need to be there. Also, make sure you only increment the recursion count if the calling thread is the owner thread. Don't be incrementing it otherwise, and this code is incorrect in that respect. Here's yet another problem I saw. Take a careful look at what the return value is for try-lock. It should be true if you acquire the lock and false if you fail to acquire the lock. So the check here is actually backwards. Here's yet another example. Again, it doesn't make any sense. You know, the value, this is an atomic Boolean. It's not dealing with strings, so that makes no sense. It's not thread safe. It's not atomic. You need to be checking the return value from try-lock, so don't just call it by itself. That doesn't make any sense either. People need to go and kind of think more carefully about what's happening here and what try-lock is doing, and think about the semantics we're trying to accomplish with this atomic Spinlock. Here's another weird problem. This code certainly should not have compiled because the person's trying to set an atomic Boolean to false, which makes no sense. There's a number of other problems I saw with unlock. The condition expression can be simplified, and I think this code is actually incorrect because it's going to essentially set things to null or to 0 if the current thread isn't the owner of the lock, which is not the right semantics. So you have to think very carefully about the semantics here. A number of people had problems with available permits. Available permits needs to use a particular method on the Java semaphore object that you're using here. And I'll let you take a look at the Java semaphore class documentation. It should be pretty obvious what the method is once you take a look at the documentation. This is obviously not the right thing to do because it's not the number of available permits, it's the total number of Palantiri, which is not the same thing at all. And I think this is the last bug that I am going to talk about. This code is way, way, way too complicated. There shouldn't be a loop. There shouldn't be non-thread safe code. This code is not thread safe. It makes no sense whatsoever. And as a result, you should replace this code with the very, very trivially simple call to the appropriate method in the Java semaphore API. So that's basically my walkthrough of the frequently made mistakes for this assignment. Please take a look at my comments on your code. Also take a close look at what's here. Make sure you understand all of the reasons why the code here is incorrect. For one reason is to make sure your code is correct for your final submission. And the second reason, of course, is that these kinds of things often appear on quizzes. So that's it for now. Let me know if you have any questions.